So this is number 25 from the Chapter 7 review. We have a system of equations, and they want us to solve it by using Gaussian elimination. So straight away, let's turn this into an augmented matrix. Now we do know that this says Gaussian. It doesn't say Gauss-Jordan. It wants Gaussian. So we're done when our augmented matrix looks like row echelon form, which is 1, 0, 0, 0, 1, 0, 0, 0, 1, with some numbers here. So let's turn our augmented matrix, if we can, into this form. So let's create a 1 here first. We already have that. Now create a 0. So what I'll do is I'll multiply row 1 by -3, and I'll add that to row 2 to get the new row 2. And let's see what this becomes. So I multiplied this by -3, add it to that. Multiply by -3, add to this. Multiply by -3, add it. Multiply by -3, add it. That's how I got the new row 2, where row 1 and row 3 stayed the same. Up next, I have a 1, 0, 1, 0. Now this needs to be a 0. So to do that, I'll go 2 times row 1 and add that to row 3 to get the new row 3. Because if I multiply this by +2, it's 2 minus 2, 0. So let's do that. Okay, so the first column looks good. It's 1, 0, 0, 1, 0, 0. I have a 0 here. Nice. Now, I could invest some time in trying to make a 1 out of this, but I'm not going to. Because if I look at the bottom row, something really, really bad just happened. You see, eventually, you're going to need this to be 1. But right now it says 0. I cannot turn that 0 back into a 1. It can't really be done per se. But what's worse than that is the statement that the bottom row says. Remember that initially we had X, Y, and Z. If we brought the letters back in, look at what the bottom row is saying. The bottom row is saying that 0 times X plus 0 times Y plus 0 times Z equals 10. Guys, 0 times X is 0. That's 0, and that's 0. What's 0 plus 0 plus 0? 0. How in the world are you going to let 0 equal 10? This cannot be done, at least not in this level math class. So because this is impossible, we say that this system of equations, we stop here and we say, hey, this has no solution. This is impossible. This has no solution because this bunch of zeros added together cannot give you back a 10. So this problem, again, no solution for number 25. The next problem, number 26, has a related conclusion. So let's try that one next. So this is the following problem, number 26 from the Chapter 7 review. And the goal is the same. Solve this system using Gaussian elimination. So first, let's write the augmented matrix that goes with this system. And we know what they want from us. They want this matrix to look like that. So let's create the 1 in the top left. Lucky for us, that's already there. Let's create a 0. So to do that, I'm going to multiply row 1 by -3. And I'll add that to row 2. Why am I doing this? To get the new row 2. So let's see what we get. Okay, what's next? Up next is to create a 0 here. So since this is a 1 and that's -2, I'll multiply row 1 by 2 and I'll add that to row 3 to get the new row 3. So I'm not going to take any more time trying to make this to look like that because of the bottom row. You see, if I were to bring the x's, y's, and z's back in, that bottom row would say 0x plus 0y plus 0z equals 0. And like the previous problem, on this side, 0 plus 0 plus 0 is just 0 equals 0. So is this true or false? Well, this is true all the time. The previous problem, this was a 10. 0 equals 10 is false, which is why the previous problem had no solution. This is the exact opposite. 0 equals 0 always. So how many solutions does this system have? This system is said to have infinitely many solutions. That's one way to conclude this problem. I don't know what your teacher will require from you. There is a different way of answering this type of situation. You could say that this system is dependent. I'm not sure if that word means anything to you. And there are a couple of other ways to answering a situation like this. But what I have here is a more common answer, just to say infinitely many solutions. So in the event that you run into a situation where it's 0, 0, 0, it all depends on what this is. If these are all zeros, and this is like a 4 or a -3 or something that's not 0, then it would be no solution, like the previous problem. But if this is 0, 0, 0, and this is also 0, then the conclusion of the matter is infinitely many solutions. And before I let you go, a quick comment. That whole situation of 0, 0, 0, it doesn't have to just happen in the bottom row. It can happen in the top row or in the middle row. Anywhere it happens, it boils down to two things. If that's also a 0, many solutions. If this is anything but 0, no solution at all. So I hope that helped. Keep studying hard.